There's always like a bit of confusion here now when we compare, or rather, when we talk about double angles or compound angles under trigonometry. So with double angles, here are the formulas of double angles. It's either cos of double angles. So we're talking about two angles. So it's an addition always. It's an addition of two identical angles. So that's why we refer to it as cos 2a sine 2a, or cos 2x sine 2x, or cos 2 theta sine 2 theta, or using any other identity, right? But then now with compound angles, it's always different angles. So it's going to be sine of x plus theta, or sine of y plus x, or sine of theta plus beta, regardless. But then we're working with different angles, whereby sometimes it may be addition, sometimes it may be subtraction. Hence, with double angles, we have the derived formulas already that are given to us in a question paper whenever we're writing an exam, which the equations looks like this. These are the double angle equations, and they are always given, mostly because it's something which you can remember, but then they are given as part of the formula sheet to remind you as to how to derive. So the selected question for today, it helps us understand the application of not double angles, but compound angles. So we selected question 6. It's a very short question. It reads, given cos alpha minus beta, like that, and then it's given. So the very same way it's given, that's how the formula for compound angles under cos theta. So if we have cos of an angle subtracting another angle, in this case whereby it's alpha subtracting beta, we're always aware that the formula will be given like that, as it is on the question, just like I've stated on all these equations here. They help us break down the whole thing. So you can see the very same way it is here. That's how it's given here. I don't know if the pointy will work by the time I finish the whole thing. But then, yeah. So now they want us to 6.1.1. They want us to use the given identity to derive a formula for cos of alpha plus beta, because the given one is alpha minus beta. And then this next one, they want us to simplify completely that expression. And they're asking me to simplify. And okay, let me just open. Hi guys, welcome to Simplify RSA, the guys who makes it looks easy. I'm Mr. My Man, and I swear to God, I'm gonna simplify 6.1.2 for you when we get there. But then let's start with 6.1.1. So this is how we do it. Now, before I start with 6.1.1, I just want you to know that feel free to send us an email or to send us a WhatsApp to inquire about our private lessons. Here's our contact numbers here. And please subscribe to our YouTube channel. Follow us on Facebook, follow us on Instagram, follow us on TikTok, follow us as well as X, yes, and on X as well. And you can also access our learning channel through Spotify. You just go to your Spotify app and search for the learning channel. Yeah, so now we can do our question 1. Let's go. 6.1. So we are given that cos of alpha minus beta is equals to cos alpha cos beta. Like I said, that's just the given formula as it is, plus sine theta sine beta. And look at the hint. When is a negative here, is a positive here. Now they want us to use the given identity to derive a formula for this. So 6.1.1, we have cos of alpha plus beta. Now, to derive this using this, it means I must express this in terms of that. Express this in terms of that. Now, to express this in terms of that, mathematically, this is going to be cos of alpha minus beta. I'm doing this because minus beta multiplied by negative is going to give me positive, but then I've expressed this in a negative so it can look exactly like that. So now I'm getting somewhere because I already have this expression expressed like that, but then while I kept the sign because negative times negative is in a way positive. So you see where this is going? So therefore, this is going to be equals to, now using this expression, this is going to be cos of alpha, cos of alpha, cos of negative beta, plus sine of alpha, sine of negative beta. Like I say, exactly now, I'm using this expression to express that because I put it like that. So it's going to be like that. Therefore, this is going to be cos of alpha. When coming to negative numbers, cos of negative number, cos of negative angle, cos of negative angle is going to be positive angle. So it's going to be cos of beta. But when you see here, I have sine alpha, which is this one. Sine of a negative angle is negative sine beta, like that. So if I rearrange this negative now will come this side. If I rearrange this now, I will have cos alpha, cos beta. Now because it's a minus here, minus sine alpha, sine beta, which then now proves exactly that cos alpha plus cos beta is equals to cos alpha cos beta minus sine alpha sine beta. So like I say, when I started, I said you must note here when it's a negative here, it becomes a positive here, as well as when it's a positive here, it becomes a negative here, like proven also in the table of the identities of our compound angles, which is given like this. So for 6.1.2, we have to simplify the following. We have 2 cos 6x cos 4x minus cos 10x plus 2 sine squared x. Now, you see, in this life, practice makes perfect. If you look at this problem here, the only thing you have double angles here. You have some sort of compound angles here, not double angles, excuse me. We have some sort of compound angles here. The thing is you can manipulate this somehow to be like something of this point, knowing or understanding how to work out your angles. Because if we have 2 cos 6x cos 4x minus, somehow I can see that I can write this as cos of 6x plus 4x to manipulate to get there, because now I understand how my double angles work from the given expression, or even if it was not given, I now know how how compound angles work. From my given expression, I understand very well how compound angles work at the moment. So now this is going to be plus 2 sine squared x. And the only thing we had to simplify here was to write this part in a form of this. So we're getting somewhere here. So this will then give me minus cos 6x cos 6x cos 4x. If it's a plus here, then it's going to be minus sine 6x sine 4x plus that part here. I shouldn't forget this part here, plus 2 sine squared x. Let me just Let me just put it like that. So we can have plus 2 sine squared x. So we're having that now. The part is added. So to continue here, we have so this multiplied by this is going to be minus this, but this negative now multiplying here, it's plus sine 6x sine 4x plus 2 sine squared x. So we just break it down like that. So we have this part here, we have this part here. But if you look properly, here we have 2 cos 6x cos 4x, and here we have minus cos 6x cos 4x, meaning we'll be left with only 1 cos 6x cos 4x, cos this 2 minus that 1 here. So now if I rewrite this, we'll be having only this one. So it's going to be cos 6x cos 4x, because this one subtracted that. And then I'm going to add that plus sine 6x sine 4x plus 2 sine squared x. So now I'm getting somewhere here. I'm here now. I have cos 6x cos 4x plus sine 6x sine 4x, right? Stay with me here. Everybody else can see that from here, I then get that cos 6x minus 4x in terms of compound angles, just like I did from here to here. Or also, because here it was a positive, here we have a minus. Because here is a plus, here is going to be a minus. And from here, everyone can see that cos 6x minus 4x is then going to be just cos 2x, which is now a double angle. And we know that cos 2x is the same as 1 minus 2 sine squared x. This is just a deeper meaning that I'm giving to from this to this, from this to that. But let's come with it. So now I have cos 6x minus 4x from this whole thing here. I simplify this into this plus 2 sine squared x. Therefore, this is the same as cos is 2x plus 2 sine squared x. Cos 2x according to double angles, I know that's the same as 1 minus 2 sine squared x plus 2 sine squared x. And then we can see clearly that this will cancel that. Therefore, our simplest expression is just going to be 1, just like that. So to simplify this, you will have 1. You can try it again and use different ways, but then it's just a matter of trying to link this and that somehow to be able to can go down and break and simplify the whole thing. But yeah, this is our answer. So that's all I can say regarding compound angles. And I wanted you to understand also the difference between double angles and compound angles. Join us on our next video as we continue simplifying stuff for you. This is Simplified RSA, and we are indeed the guys who makes it looks easy, your #1 learning channel. Please don't forget to subscribe on our YouTube channel. Follow us on Facebook, follow us on Instagram, follow us on TikTok, as well as on X. And now you can also access our learning channel through Spotify. All you need to do is just to go and search for the word learning channel on the Spotify app, or alternatively, you can just type in simplified_RSA. I'm Mr. Mayamane. Until next time. Oh yeah, and please don't forget to feel free to can send us an email or a WhatsApp message if you want to inquire about our private lessons. But furthermore, you can just send a random question that we may have in mathematics or physics, and then we may solve it in part of the videos. And yeah, that's how we do. Our contact numbers will be here. But then for now, until next time.